There are two rules when you're balancing chemical reactions. The first rule is that you are only allowed to use whole numbers when you're doing your balancing. And the second rule is that you are only allowed to put the whole numbers in front of the compound. You can't squeeze whole numbers into the formula, okay? You got to put them in the front. Now, the best way to approach any balancing problem is to make a list of all of the reactants on one side and a corresponding list of the products on the other side. Then you need to tally up all of the atoms on one side and all of the atoms on the other side. Now, I like to put things in the same order, going down, because it just makes your life a lot easier. So let's see if we can figure out how many sodium atoms are on the reactant side of the reaction. How many? 1. How many are on the, or how many chlorines are on the reactant side? 1. Oxygen? 3. Very good. On the product side, how many sodiums?
1.
Chlorine?
1.
1. And oxygen?
2. Oh, this is easy.
So far, yeah. You're just adding things up. Now, we notice that there's everything's balanced except for the oxygens. There's 3 oxygens on the reactant side and 2 oxygens on the product side. Okay? So, I like to think of this as the lowest common denominator strategy. Because if you're trying to balance a 2 with a 3, perhaps this comes to mind. If you were going to add these together, these fractions, 1/3 and 1/2, what would you look for? Lowest common denominator, which is what? 6. And in order to get 6 over here, multiply by 2. In order to get 6 over here, multiply by 3. So we'll do the same thing. The oxygen on this side, I'll multiply by 2. But look, I got to put the 2 in front of the whole chemical. Now that gives me 6 oxygens. But it also gives me 2 sodiums and 2 chlorines. We can deal with those later. On the product side, I need to put in what number? 3. And that'll get me 6 oxygens on this side. Now you might be able to see very clearly how am I going to get my sodiums and my chlorines balanced. The 2 right here take care of the whole thing.
Wait, how did, so because you made it the common denominator, how come it's not 3 on the reaction side of this? Yeah, wouldn't it be 336? Not on that side, on the other side. Other side. Yeah, wouldn't it be 336?
Well, I put a 2 in front of the sodium chloride, so there's
Why did
only
you put a 2?
Well, there were 2 on here. When I put the 2 here to get 6 oxygen,
Yeah.
that automatically made this sodium a 2 and this sodium a 2, chlorine a 2.
Okay.
So I had to balance those out to 2. So I put a 2 in front.
Oh,
there.
They were equal before?
They were equal to when we started. We messed them up on our way.
Oh, so we have
we
to
gotta
keep
fix
everything
it.
balanced?
Everything's
so,
got to be balanced.
Oh, basically what you do to one side, you have to do the other?
Sort of. You have to have the same numbers on either side. So you do whatever you got to do to get the same numbers on either side.
Oh, okay. All right.
All right. Last, before we move on, using your definitions, what type of reaction is this? We have sodium chlorate as a reactant, and we have 2 products. What type of reaction is it? Anyone?
A good one.
A good one.
Is it?
It's not combustion. Louder. Thought I heard it. Decomposition. We have one chemical decomposing into two other chemicals. So it's a decomposition.